We had some good conversation come up over here a minute ago. So, in case it hasn't settled in on you, how close we are to the end of things. Okay. So we've got 9-3 today, 9-4 Wednesday, a week from today's test review, and then the 17th is test 3. And so if you're happy with your test 3 grade, you'll know it by the end of Thanksgiving. Okay. If you're happy with your test 3 grade, next Wednesday will be the last day you have to come to this class. So, okay. If you need to take the final exam, we will review on the 29th, that Monday after Thanksgiving break. Okay. And then our final exams, whenever it says on the final exam schedule, I don't remember, but technically there's classes on December 1st. We won't meet on December 1st. Okay. Mm-hmm. Okay. So we're halfway through. We'll be 3/4 of the way through with the financial chapter after today. So good news is that we don't have too terribly many more formulas we have to go through. So that's kind of the downside of this chapter is we just have, it all just boils down to a bunch of formulas. Okay? So that in and of itself is not that interesting. Okay? Remember, we're trying to get at least a little familiar with what the formulas are doing, and that's the big deal. Okay. All right. Anybody think of anything we need to talk about before we get into it? Any questions or anything? Everybody getting ready to get registered for spring? I started on that. Got you. Getting ready. Just spring registration starts. When is it? In a day or two? Yeah. It started today. Yeah. In the spring, I have 2 204s, which is statistics, and then I have a 112, which is pre-calculus algebra. Most of you probably don't have to take that since you're in here. And then I have 125, which is calculus 1. So that just has happened. So how hard is what? Statistics. It's not bad. Most of the math's in calculator, so it's a little more conceptual in statistics. So. I do not think 204 statistics is as hard as 112. So I think 112 is a pretty good bit harder than 204. Okay. Anything else? Yeah. All right. So we'll get into this section then. I think we have three formulas in this section we have to deal with, and really just 2. One of them just rearranged. Okay. But we want to be able to work some of these problems. So we're focusing on saving money in this section. So we talked about interest a little bit last time. We were mainly thinking about it as being money that we have to pay if we borrow money. Okay. That's not always the case. We're saving money, we're making some type of investment, interest is really nice. Okay. It can really help us out there. One way rich people stay so rich is they use interest. Okay. So let's look at our first formula. So in these, we're going to be thinking about really 2 types of investments, 2 types of ways we can save money. So one is if we're making like a shorter term goal, like we want to be able to make a down payment on a car in a couple of years. So we're going to save money for a couple of years toward that. And then The other one's more long-term, like we're thinking about more like retirement planning. So we need to end up with some certain amount of money to be able to retire 25, 30 years from now. Okay, something like that. Okay, so kind of treat those two situations a little differently. So let's look at our first formula here. It looks a little scary, it's not that bad. Okay, so this is our formula for present value. So this is how much our money is worth today. Here's present value. And we're familiar with most of these variables in here. We've seen them before, except we have seen A before, but now we're calling it something different. Okay. A, we're calling our future value. And then the other numbers we've already dealt with. We've got R is our interest rate. Remember, that has to be in decimal form. N is our compounding intervals, how many times we're compounding interest per year. And then T is how many years we're letting pass. And all this formula really is, it's just rearranging our compound interest formula. So this was the formula we use for compound interest. So really all that's been done is we're dividing both sides by the stuff in parentheses, and instead of principal, we're calling it present value. So just rearranging that formula there, just off for a different variable. Yeah, let me put the slides up. I don't know why I always forget for this class. One moment here, let me get these slides posted on Canvas. And then we'll pick right back up. Wi-Fi's been a little slow as usual in here. Get to see all behind the scenes on Canvas if you care about any of that. Okay, this should be there now. You refresh. Okay. All right, so there's our formula. So the idea of what we use this formula for is we're going to say if we want to end up with this future amount of money, and then we're going to invest it at a certain interest rate over for a certain period of time. Those numbers are given to us, but if we want to end up with a certain amount of money in the future, how much do we need to invest now? That's what we're using this formula for. All right, so let's look at our first problem. Okay. This one says, State College predicts that in 18 years it will take $150,000 to attend the college for 4 years. Ugh. Amber has a substantial amount of cash and wishes to save money for her newborn child's college fund. How much should Amber put aside in an account with an APR of 4% compounded monthly in order to have $150,000 in the account in 18 years? So if we have this money we can invest in a lump sum now, okay, where we just make all the investment up front, how much would we have to invest to end up with $150,000? Okay. That's what we're looking for. So our future value, the amount we're trying to end up with, $150,000. Okay, we're going to leave it in there for 18 years, so that's T. Our APR, our interest rate, is 4%. So remember, we want to change that to a decimal for our calculation. So 0.04. Okay. And then the only other thing we need N, how often our interest is compounded. And this says it's compounded monthly. So what do we use for N? How many months are in a year? 12. N's 12. So remember, we had those different values for N, like we had semi-annually 2, we had quarterly 4, monthly was 12, daily would be 365. Remember. Okay. So if we can pick those numbers out, then our challenge is just being able to punch all this in our calculator. Okay. It is a little bit tedious, and you can see in this section as we go through the formulas why I really recommend you have a calculator where you can see what you're typing in. Yeah, I said the scientific calculator because that's true for most of those. All right, so let's see, here's our formula again. So the amount of money now we need to end up with the amount of money A. Okay. And we can plug our numbers in here. So the amount we want to end up with is 150,000. I'm going to divide that by 1 plus R over N. R was 4% here, so 0.04. Compounded monthly, so N is 12. Then we have N again, so 12 again. And then we're going to leave our money in there for 18 years. To let our newborn child get to college age. Okay, so the way I punch this in my calculator usually is I will do the bottom part. Okay, so the part in parentheses and raise that to a power, and then leave that answer in my calculator and do 150,000 divided by that previous answer. So most scientific calculators at least have a little button on there where you can use your previous answer. It saves it in there. Mine says A and S down at the bottom. Some of them look a little different. So if I do the bottom part, I got 1 plus 0.04 divided by 12. Close my parentheses. Raise that to the 12 times 18 power. Just if you want to check what you get there, I get 2.0519 something. Okay. If you're going to write that number down and then use it again, instead of just letting your calculator save it, you want to leave a bunch of decimal places. Okay. Because if you drop off too many decimal places, it will affect our final answer we get. Okay. So I've got that number saved in here, and I'm going to do 150,000 divided by that previous answer. And I get $73,100. It rounds to, well, it stays at 31 cents. Okay. So we took this amount today, invested it at this interest rate, compounded monthly for 18 years, we would end up with $150,000. You may have calculator questions or 12 times 18. So on mine, mine has a button that looks like this for the exponent. Some of them have a button that looks like that. So I take the parenthesis part, and mine just makes the numbers little, and I just put 12 times 18 up here. If you have the little rooftop symbol on yours, you would have the parenthesis part and then the little rooftop symbol, and you probably had to put parentheses after that. Do 12 times 18. So that parenthesis part raised to the power is like 2 point something. Yeah, I think yours has a little rooftop. Yeah. Questions on that one? Okay, so let's talk about kind of applications of what's going on then. If we can afford to part with this number, okay, it's like paying this amount for a college education instead of paying $150,000. Right? It's a little unrealistic for most of us to have a lump sum of $73,000 we can just put away and not think about for 18 years. When that type of thing would happen would be like if you got an inheritance, or you had some kind of insurance settlement, or if you won some money in the lottery or something like that, then that's when you would probably think about doing some type of lump sum investment like this. Okay? So not for everybody. Okay? But if you can do that, then that's good. Okay? So one other thing to mention here, okay, that interest rate of 4% is not great. Okay? So typically you get, if you're gonna leave something invested for 18 years, you could find the interest rate a little bit better than that. On average, so what we're dealing with here, let me back up a little bit. What we're dealing with here is we're fighting inflation, right? We're fighting how prices naturally rise for things. Right? If you talk to your parents or your grandparents, they'll talk about, you know, when I started driving, gas was 57 cents a gallon and things like that, right? Price just naturally goes up over time. That's what we call inflation. Okay? And typically that averages out to about 3% per year. Okay? So the fact that we're getting 4% interest here means our money is going to grow a little bit faster than inflation. Okay? Which is what you want. You don't want, for sure, you don't want our interest rate to be less than inflation, because then really you're losing money. Something to think about there. Okay. No questions on that one? We're good? All right. Let's look at another one. If you have $0 available to invest at the moment, I know it kind of makes this a little more boring, right? What's the point if you don't have any? I'm with you. Been there. So let's look at another one. Do one more of these. This one just doesn't give us all the backstory. It just tells us what numbers to use. So this one says, how much should you deposit now in an account with an APR of 7%, compounded monthly, if you wish for the account to have a balance of $200,000 in 25 years? So our interest rate, 7%, so 0.07 in our formula. Again, it's compounded monthly, so n will be 12. We're trying to end up with $200,000, so that's our future value, or the way they've got it written in this formula, A. And then 25 years, so this T will be 25. Okay. So, looking into our formula, 200,000 over 1 plus 0.07 over 12. And then in our exponent, we have 12 again times 25 years. Let's see what we get this time. Better interest rate this time, and we're leaving it in for longer. So 1 plus 0.07 divided by 12. Raise that to the 12 times 25 power. If you're checking yourself there, I get 5.725 something. 200,000 divided by that number tells me if I want to end up with $200,000 in 25 years, I need to invest $34,931 and rounds to 95 cents. Let's see, 5.7254 or something goes on and on. That's from the parentheses part raised to the exponent. Okay. Questions here? So these problems boil down to really two things. You need to know what the different letters stand for so you can get those numbers out of the problem and get them in the right place. And then you need to be able to punch it in the calculator. On the test, I'll ask you for this part where we've got the numbers filled in as well as what you get out of the calculator. Okay, because if I just have this last number and it's wrong, it's really hard for me to give partial credit. But if I can see what you did here, then it's a lot easier for me to see things like, oh, you accidentally put 24 instead of 25 or something like that. And then even if this number's wrong, I can still give you most of the credit because you know what's going on. I'm not like super interested in grading you completely on whether or not you can type something in a calculator. I would rather that be a small piece of what's going on. So I'm going to ask you for this piece too. All right, so again, most people, there are people out there that could make this investment today. Okay? I'm not one of them. Okay? Guessing most of you are not. Okay? So this is a little unrealistic, okay, for us to be talking about, well, I'll just invest $35,000 today and then in 25 years it'll be $200,000. So we will have a formula that's for the rest of us, okay? We'll see in just a minute. That formula, if we want to invest a lump sum, that's what we use. Okay? So a different way to make a similar type of investment, where we're going to make a longer term investment, is using something called an annuity. Our definition just says it's a sequence of regular payments either made into an account or taken out of an account over time. So since we mentioned the lottery, if you do win like a big number on the lottery or something like that, then they give you two options on how to get the money. They'll either give you a lump sum, okay, which is just one big payment. But if they do that, so let's make the numbers easy. So like if you won $1 million, they'd say, okay, we'll give you $700,000 now. Probably not quite that much, but $700,000 now on one lump sum, or they'll do an annuity where they're like going to pay you $1,000 a month for the rest of your life, something like that. So you have options there. Here, since we're talking about investing, how that would work is that we make a monthly payment into an account, and it gets interest and grows to a certain period of time. Lots of times we're thinking about retirement, and it's a common place to see these. So we're going to make a payment into an account until we hit retirement age, okay? And then we'll have some certain amount of money built up by then. That's an annuity. You see that term? So investing money in this manner where we're making a regular payment, like maybe we're investing a certain amount of dollars every month or something like that, that's a little more typical on how most people end up investing money for retirement and things like that. So let's look at the formula. Formula is a little bit messier. The only thing new though is this PMT term, and that's just the payment that we're making, the regular payment, what however often it may be. So I think in most of our problems, we're going to be thinking about monthly payments. So this is how much we're paying into our account every month. And then we can figure out how much we'll end up with after a certain amount of time if we're drawing a certain interest rate and we're compounding it a certain number of times per year. Or here, you can also, don't necessarily think about compounding. Certain number of times per year, you can think about N as being the number of payments we're making each year. Back up, yeah. One thing to mention on the formula, the textbook puts those brackets around the top. You don't really need those. They're just kind of putting them there to help you see what's going on. That makes it a little bit better when you're typing it in. You don't have to have those top brackets. You ready? Use it. Okay. So, look at the problem. It says Daigle begins placing $75 per month into an annuity savings plan when he begins receiving his first official paycheck in August 2014. The savings plan earns 2.5% APR compounded monthly. Determine the amount of money that Daigle will personally put in the savings account plan over 10 years. And we want to figure out the future value. So part A, where we're figuring out how much the person's actually paying into the savings plan, we don't need a fancy formula for that. Because he's paying $75 every month for 10 years. That's all we need to know. So we just need to figure out how many months 10 years would be. That one's not too hard to do. And so on part A, we got 10 years times 12 months in a year. Tells us he's going to make 120 monthly payments. And he's paying $75 each time he makes one of those 120 payments. So 75 times 120, he's going to pay in $9,000. Okay. That's it on part A. That's how much is coming out of his pocket. Part B, we will use our formula. It says calculate the future value of his savings. And I don't know why it does this. It says 10 years on part A, but then it tries to act like we're going to have to figure out how many years it is on part B. Okay, if this is all we had, August of 2024, you do 2024 minus 2014 is 10 years. Okay, so 10 years on both of these. So T is going to be 10. Our monthly payment, PMT, is 75. 2.5% APR tells us R is going to be 0.025. Change it to a decimal. And then we're making monthly payments. And they're going to be 12 again. Okay, so let's plug into our formula. Here, I'm going to write the formula down again. We want to know the future value, and we're making payments. So we're going to have our payment times 1 plus R over N, the NT, minus 1 over R over N. On this problem, when we plug our numbers in, the payment was $75. interest was, what was it? 0.025. Monthly payments, so N is 12. And then we've got 12 times the 10 years in our exponent. And then the bottom, 0.025 over 12. So this one is a little bit trickier to type in. What I'm gonna do is I'm gonna do the parenthesis part on the top first. Okay, so I'm gonna do parenthesis 1 plus 0.025 divided by 12, close parenthesis. Raise that to the 12 times 10 power. There I get 1.28 something. Minus 1. And then I'm going to divide that answer with parentheses by 0.025 divided by 12. Okay, so there I got 136 point something, and then times 75. Okay, so he's going to end up with $10,212, and that rounds to 90 cents. Okay. So out of pocket, okay, he paid in $9,000, but it's worth $10,212.90. Okay. Yep. Just figure out how many months it is, and then multiply those months by how much he's paying each month. All right. So this one's not all that impressive. Okay, like that you end up with that much money after 10 years. It's not all that impressive for a couple of reasons, maybe 3 reasons. Okay. 2.5% is not a good interest rate. Okay. Remember, we said about 3% is inflation. So really, this is not even keeping up with that. So not a really good choice of investment. He's not paying all that much per month. Okay. But then the big contributor here, other than the interest rate, is that he's only leaving it in there for 10 years. Okay. So kind of remember, the power of compound interest is that the longer you leave it in there, the faster it grows. So here, 10 years is just really not enough time for this to pick up steam and start growing really fast. So that's why one reason why you don't want to wait till you're 10 years away from retirement to start saving for retirement. Okay. You want to try and start as early as you can. Okay. Question on that one? Calculator issues or anything? If you're putting it in all at once, so are you starting with the 75? I would actually wait, because it makes it a little more confusing to start there. So if you're gonna, you could put this thing in, and then do times 75 at the end. Yeah. Just makes it a little trickier to put that 75 in first. All right, hang around when we get done, and we'll figure it out before we go. It should be something I just have to watch what you're typing and see if I can see what's going on. Me too. All right, we'll get it figured out before we leave. Okay. Oh, there's that one. Okay. Let's look at another one. Okay. All right. This one, kind of another illustration of why annuities are not all that impressive if you're not going to leave it in there long. This one says use the annuity formula to calculate the future value after 6 months of monthly $50 payments for an annuity savings plan having an APR of 12%. Okay, so the weird part on this one is we're only leaving it in for 6 months. And remember, our time T needs to be in years. So 6 months is only 1/2 of a year, or as a decimal, that's 0.5, right? You could say 6 out of 12 months, or 0.5. We're doing monthly payments, so N is 12 again. Our monthly payment is $50, so PMT is 50. And R, 12% interest, so R will be 0.12. And good interest rate. This one's just not in there for long. It's only in there for 6 months. So we plug into our formula, our future value is $50, our payment, times 1 plus 0.12 over 12 to the 12 times 0.5 power. We got -1. Let's see what we end up with on this one. 1 plus 0.12 divided by 12 raised to the 12 times 0.5 power. So on there I get 1.06 something -1 divided by 0.12 over 12 and times 50. And I think I made some kind of typo. Let me try one more time. Sorry. Yeah, there we go. So that one comes out to $307.60. So if you check how much we would have paid in on this one, so 6 payments of $50, that would be $300. So we've only made $7.60 of interest. And the big problem with that, okay, why that's happening, because T's so short. Okay? It's a good interest rate, but T's so short, so it just doesn't have time to start growing really quick. I would love to get 12% interest on my retirement investment. Okay? That's a good interest rate. You just have to leave it in there longer before you're impressed. Okay? So in that case, if you're just going to save money for 6 months, most of the time it's not worth it going through the trouble of setting up an annuity or something for it. Just put it in a savings account. Okay? They don't draw much interest, but I mean, what's the difference? We're going to lose like $2 or $3. Okay. Questions? Hang there. Hanging in there, hang in there. We got one more formula. Okay, one more formula. Okay. Oh, okay. We got one more example and then one more formula. Sorry. This one's a little more interesting. This one's more set up for how you should use annuities, okay, for a long-term investment. All right. It says at the age of 25, Angela starts an IRA, which is individual retirement account to save for retirement. She deposits $200 into the account each month. Based on past performance of similar accounts, she expects to obtain an annual interest rate of 8%. Okay. So part A says how much money will she have saved at the age of 65? And then we're going to compare how much the account is worth versus how much she actually paid in. Okay. This one's more impressive because we're leaving it in there longer. Okay. So she starts at 25 and she ends at 65. How many years is that? Forty. 40. So T's going to be 40. R, 8%. So for R, we use 0.08. Our payment, PMT, $200 a month. Since it's each month, N will be 12. Okay. Let's figure out how much money she's going to have. Okay, so for our future value, we've got our $200 payment times 1 plus 0.08 over 12 to the 12 times 40 years minus 1 over 0.08 divided by 12. Okay, so on this one, she will end up with $698,201 and it rounds to 57 cents. Okay. That's part A. Yeah, that's a lot of money. That's more like it, huh? More like it. Okay. Now, part B is where it gets interesting. Okay. Because part B, we figure out how much of that she actually paid in and how much of that has she earned as interest. Okay. So how much she pays in, we're thinking about like how much of that did she have to work for, and then how much of that did she just earn in interest. Okay. So part B, we just need to figure out how many monthly payments that is, right? So it's 40 years. Times 12 months in a year. So that's 480 payments of $200. So $200 times 480. How much of that did she actually pay? She paid in $96,000. Yeah. So she has paid in $96,000, but it's worth almost $700,000. Yeah, so there's where our compound interest starts looking impressive. Okay, that's where it starts looking impressive. So roughly $600,000 of interest. That's nice to have $600,000 that you didn't have to pay in yourself. Right? I would call that $200 a month well spent. Okay. How much money do you need? So the end goal on most retirement planning, okay, and that we're taking out like, you can get away, like if you're gonna draw some Social Security and things like that, and you had other things, you can subtract that away. But if you didn't have any of that, just to boil it down to the simple version, you want to end up with a sum big enough, okay, that when the next month comes around, okay, and you get the interest, that interest is enough for you to spend that month without having to cut into the balance, right? So like if it takes you $2,500 a month to live, right, And that just depends on what kind of lifestyle you want to have, okay, for different people. So if you want to have, $2,000, $2,500 a month, whatever, to live off of, then you want a lump sum big enough that at whatever interest rate you're getting, you're going to get $2,500 a month interest. Okay? Which sounds unreasonable, but it's not. It's not. This would depend on the interest rate. That's getting close. That's getting close. There are calculators that you can use to figure out. It gets, it's kind of individualized because you want to figure out how much you would want to live off of. So usually, like if you go to a retirement planner or something, they figure out you want to draw an interest about 70% of what you were making when you were working, and whatever that comes out to per month. Figure out how much interest you need to draw per month, and then you can figure out the total amount you need to end up with. Okay. So big long chain of questions you have to answer to get there, but you can figure it though. And that's the ideal situation, right? Where you're not cutting into your original balance, because that way you could, in theory, you could stay retired forever. You could live to be infinitely old, and you would always be living off this amount of money. Okay. That doesn't happen. Okay. So then you can make the amount smaller when you're thinking, well, I'm planning on living 25 years after I retire and things like that. But a lot goes into it. Okay. All right. One more little piece here, and I'll just give you the answer on this one. Okay. So in that one, she started investing at 40 years, right before she retired. Okay. Retiring at 65. Started at 25. On this one, we're saying what would happen if everything else stayed the same, but instead she started when she was 18. Okay. So 65 minus 18, yeah, that's 47 years. So how much more money would those extra 7 years get her? Okay. If you do the same formula and just change T to 47, there, what we get there? Okay. 1.24 million. Okay. So the point I'm trying to make with the time being a big deal is we only added 7 years, okay, out of 40. We only added 7 years, and we almost doubled the amount of money we had. Okay. And if you went 7 more years, it would be real big. But nobody wants to wait till they're 72 to retire, so most people don't. All right. Any questions? Good. All right, one more formula. And really, it's the same formula. So what we've been doing, okay, all right, we've been saying how much of a monthly, or no, if I make this monthly payment for so many years, how much is it going to be worth in the future? But sometimes that's not what we want to ask. Sometimes we want to say, how much money should I invest every month to end up with a certain amount in the future? Right. So we can rearrange our formula. That's all this is. And it's really the same formula, just all that's happened is everything's flipped. Okay? So we solved it for PMT instead of future value. So now PMT is over here, and all that happens on this side is we flipped. Okay? So R over N's on the top instead of on the bottom. That lets us solve for our payment. Okay? So we use this formula if we want to end up with a certain future value. How much should we pay each month? Okay? So like if I want to retire a millionaire, and I know my interest rate and how long I'm willing to give it, how much should I pay each month? How much should I invest each month? So Let's do one of those. Okay. I don't like this one. We're skipping this one. Go on to just the last one. Okay. This one says Amber wishes to deposit a fixed monthly amount into an annuity for her child's college fund. So it's like the first one we did, except we're not saying that she had some kind of windfall and had a big lump sum to invest. Instead, she's doing college planning like most people have to do and figure out how much to put away each month. We still want to end up with $150,000. Still have 18 years to come up with it. Here we're assuming an APR of 4%. R is 0.04. We want to end up with $150,000. Our future value. T's 18 years. And we're going to make monthly payments, so N's going to be 12 again. Okay. So use our formula. This one's just upside down. Okay, this time we're solving for the payment we need to make each month. Here's our formula again. Okay. Plugging in our numbers, we want to end up with $150,000. Our interest rate is 4%. We're making monthly payments. For 18 years. So how much should we invest each month? Okay. So I'm going to do the top, 0.04 divided by 12. Hit equal, and then I'm going to do divided by that bottom part. I'm going to do double parentheses, okay, because I want to divide by this whole thing. Okay. So 1 plus 0.04 divided by 12 to the 12 times 18 power minus 1. There I get 0.003 something, and then times 150,000. Okay. So 475, and it rounds to 30 cents. So it's about $475 a month to end up with $150,000. And part B says how much of that did she have to actually pay in. So that's the easy part. Right? So she's doing $475.30 times 18 times 12 months, 216 months. So she's paying in $102,664.80. So almost $50,000 interest. So the smart part about this one, this is a smart thing to do, okay, is spread out over 18 years. She's paying $102,000, almost $103,000 for something that cost $150,000. Okay, so roughly $47,000 savings there. It's not easy to come up with, for most people I wouldn't think it's easy to come up with $475 a month for 18 years, but you could do part of that at least. Okay. And again, that 4% interest is not great. Questions? Did you survive? mostly. We only got one more formula section, okay? I know they're not super exciting, especially if you're broke. Right? Nobody likes talking about money if you don't have just a bunch of money laying around to do something with, so. Okay. All right, that's it for today, okay? If you didn't get on the sign-in sheet, make sure you get on there before you leave. Calculator stuff, let's do calculator stuff. Let me go back to that other problem. Let me stop this recording.